My name is Stuart Williams, and I'm going to talk to you about a project we run on pipeline welding. Our project is about pipeline welding and how to do it much more efficiently than has previously been done before. Typically, when you want to weld a pipeline, such as this, the pipe is often 25 millimeters thick, and we do a root weld followed by several fill passes. This is very labour and time expensive, and we've been looking at new ways to enhance this process. We've done this with three aspects. The first is we look at the material that the pipeline is made from. Previously this was a material called X65. We've swapped that to X100, which has a much higher strength. The result of this is that we can change the pipeline thickness from something like this, which is about 25 millimeters, down to about 20 millimeters. You can understand the benefit of this if we consider the application that we're looking at, which is the Trans-Alaska gas pipeline that's going to be built. For that particular pipeline, 2.5 million tons of steel are required. By reducing the wall thickness down from 25 to 20 millimeters, we can reduce the amount of tonnage of steel, both the purchase cost and the logistics of getting it out into Alaska. For that particular project, this is going to lead to, it's estimated, around about $500 million worth of saving just for that one pipeline. So that's the first aspect that we're looking at. The second aspect is how to fill up this gap much more efficiently. The normal way of doing that is to use a single wire process. We developed some new processes which utilize 4 wires at once. So the consequence of that is that for this particular pipe, normally we would require to have maybe 8 or 9 fill passes. For each fill pass you have a welding station, several welders and associated people. By using the process which has 4 wires rather than 1, the number of fill passes is reduced down to either 3 or 4. This leads to, again, a very large saving in cost for production of this particular pipeline. For example, instead of using 2 winters to build a pipeline, maybe only 1 winter would be required. Again, the estimated saving is round about $500 million. And the third process we've been looking at is how to do this first weld here, which is called the root weld. Normally, the rate at which you build a pipeline is determined by how quickly you do this first pass. And normally it's done at 1 meter a minute. So the rate at which you add new pipes on is determined by this. Using laser hybrid welding, we've been able to develop a process that enables us to weld these parts at 4 meters a minute. So we can build the pipeline 4 times faster than previously. Again, we're looking at roughly like $500 million of saving for that particular pipeline. And of course, these techniques can be utilized in a wide range of other applications, such as offshore pipelines.